Cool, welcome everyone. My name is Matt. I'm a software engineer at Parse. And today I'm going to talk to you guys about Backbone.js, which is the framework that we use to build our own JavaScript SDK. And I'm going to talk about our JavaScript SDK, and of course, games. So what I want to do is kind of go through a summary of how to use Backbone, why it's a really cool framework, and why we picked it. And then talk a bit about how you can create some really cool game features, both client-side using Backbone, and server-side using Parse and Cloud Code. So first, Backbone. Why did we pick Backbone? Well, Backbone is this MVC framework for the web. So there's a few of these that exist, like Ember.js, Angular.js, Knockout. And they all kind of do the same thing. They help you organize your code and throw events around, help you not have spaghetti code everywhere. But we picked Backbone because it's a very flexible one. And as you'll see today, I built a game using Backbone, which is kind of an atypical use case. It's really easy to kind of organize any kind of code using Backbone. And it was a great fit for Parse because we're trying to build a JavaScript SDK that would help you persist your data to the server, right? So that's what Parse does. And the model for objects was really, really clean and kind of helped us build that Parse SDK. So how does Backbone work? Well, let's take an example. If you're trying to build a game, or really any kind of app, and you have, let's say, a game view, and that's where your user plays your game, maybe you have like a rocket ship shooting stuff around, and on that same screen somewhere, you have some kind of label, and that's showing your user's score. And then somewhere else, maybe on the other side of the screen, you have a profile, and you see a little picture and your achievements. Well, what happens when I score in this game? So I destroy a ship. Well, I need some way to tell the score view, all right, well, update that label with a new value. Maybe that score gave me a new achievement, so I got to update that profile with a new achievement. And maybe that achievement gives me a faster game, so I got to update some stuff in my game view so the ships go faster. So I have to do all this stuff, and you basically end up with this. Everybody's talking to everybody, and you have spaghetti code everywhere, and you can't maintain this. It's not bad with 3 views, but imagine 6 or 9, n-squared lines gets pretty bad. So how do you fix this? Well, Backbone fixes this with events. So events will basically go from a model to a view. And you can have multiple views listening on that exact same model. So in the example I just gave, we could have some kind of model that is listening, or that is storing some kind of data, like a score, like my list of achievements, like the speed multiplier, anything you want. And whenever one of those change, it'll trigger an event. And I can have all these views that are just listening for these events. And the score view listens for the score value, and when that changes, it simply updates itself. That's simple. So let's actually write that example in Backbone. So you'll start by creating a model. You just call backbone.model.extend, which is the way you subclass an object in Backbone. And then you have 2 important parts. The first is the defaults. You can have some default values. A Backbone model is basically a key value bag. So you can really at any time put whatever you want in it. You don't have to put in these defaults, but it's a cool place if you want some default values. And next, you can have just arbitrary functions. In our case, let's say we want an increment score function. And we want that because our score is not just +1. We want to do +1 plus the multiplier for some reason, not times. And anytime you call increment score, it'll change that score value. So when you create a new score, you instantiate it. You can do new score model, and then call increment score on it. Now, what happens when I do this? Well, there's 2 events that are triggered. One's called a change event, because something changed in my model. And then a change score event is triggered, to say that, in particular, my score value was changed. So that way, anybody who cares, like the score view, can just listen for this and do what it needs to do. So let's take a look at that score view. Again, very similar signature up there. You have backbone.view.extend. The interesting thing is, at the last line, when we instantiate that view, we'll actually pass in the model. And that's how the view is going to listen for events on that model. So again, there's 2 important parts here. The first is the initialize function. So you'll say this.model.on. It's very like jQuery-like syntax. And you'll say when the score changes, so when the change score event is triggered, call the function render. And render is that second important part. So every view, by convention, has a render function. There's nothing special about that name. It's just a convention in Backbone. And here, all I'm doing is creating a new element in jQuery. Really, it's just a p tag, and I get the score value, set it, and then I add that to my DOM. That's really all it's doing. But the really cool thing here is that as soon as that score changes, I'm listening for the event, the render function gets called, that render function adds that new value on the DOM. So that means basically I have to do nothing. With just these two classes, this view will always be up to date with whatever my model is storing. So my game view, I make a new point, just updates the model, and this changes automatically. My profile, for some reason, changes the score value. It'll just update automatically. Anybody can change it. So we basically have score, change score, and the score view. Now, there's two other cool classes in Backbone that we won't really talk about today, but are really still useful in some use cases. The first is a Backbone collection. That's really just an array of model. That's all it is. And the cool thing is that beyond being just an array, it'll trigger some events for you. So if I add something to that collection, I'll have an add event trigger. If I remove, a remove event, and so on. So it's really just a nicety for things like lists. If you have like a list of results or a list of to-do items, a collection can come in handy. Fourth, there's a Backbone router. The router has a very particular use case, and that's for managing hashes in your URL. So let's say you're making a single-page app where everything is done AJAX, and you're not reloading pages in between clicks. You can use Backbone Router to help you manage those links. So you can still deep link into, let's say, myapp.com/photos/1, and that will, through the router, directly show me that one photo instead of me having to, somehow click through everything again. But we won't really talk about those two too much today. So before we start getting into some more code, I wanted to show you guys an example of basically a Backbone app. And it's a game called Any Oak. Can we switch to the computer? All right, so here's Any Oak. It's a very simple game. Click play here. And notice up top here I have a level label, a score, and lives. So I have eggs falling on the screen. If I miss it, it'll just fall down and crack. And you can notice here the lives changed. Now, if I click on it enough times, it'll fly away. Oh, there we go. And there you go, I survive. Keep going. And notice the score changes as I do that. And here, let's 3 fall down. And there you go, I'm dead. I got 3. Then I can go back to the menu, can take a look at the high score, and notice these transitions between each views, because that'll be pretty cool to see how that's written. And even the credits, same thing, just another view that shows up. So let's see what the code looks like. The first important part is this game state right here. Now, the game state is really just a Backbone model, as you can see, but it's not a model you're persisting to the server in any way. It's really just there, and it's a transient model, where you'll set some stuff like what screen I'm currently looking at, what's the score, what's the lives left, what's the level. And all this data is just shared between all these different scenes. Because as you saw, the game over scene, for example, had the score. We had the game scene, had all these different labels showing these values. So they all just share that same data through the state object. Here I have some default at the top, an initialize function that adds some event handlers. And then if we look lower here, we have scenes. The first one is the menu scene. A scene is basically a Backbone view. And I made a few of these that represent each screen you see in the game. So there was that main menu, there was the high score, the credits, the game, et cetera. And these are all just Backbone views. But the special thing here is that I listen on an event called change scene for a scene attribute on the state object. So anytime that value changes, all of the scenes will all call the same render scene change function. And that's down here. And all it does is says, OK, well, was I the previous value for this before it changed? If so, I'll do my little removal animation. Am I the new value for this attribute? If so, I'm going to render myself. And so just with these two powerful things, all the transitions between my scenes are really easy. So I want to add a new scene. I don't have to try and figure out how they all interact with each other. I simply write this function, figure out how I want it to remove itself, how I want it to add itself, and that's it. So it's all very localized into that same class. So if we look at another one, the game scene, you can see here in my initialize, I'm listening to more than just the scene. I have a bunch of other stuff, notably the score, the example we just saw. So the score in this game works exactly the same as the first example we saw. It calls render score. Same happens for lives and level. If we look at one of these, render score, it's a little more complicated than the example I showed, but pretty much the same thing. It just appends the right thing, creates some DOM elements, and that's really it. All right, so can we go back to the slides? So this is basically what we just saw. We had a backbone model, the game state, triggered a bunch of different events, and we had all these scenes listening on it. There's one thing I didn't show, and that was the egg model. So if you notice the eggs that were falling, actually use a model to back that, and that represents the state. So how many times did I click on it? Is it broken? Am I doing the little animation to show it breaking? And there's a view attached to that as well. And that works the exact same way. I have events every time you click on it that draws a little cloud, same thing. So we have all this cool backbone stuff. So where does Parse come into play? Why do you even need Parse? You have this cool game. Well, Parse is all about the server side. So Parse, we basically took Backbone, and we replaced the two model-driven things. And that was the model and the collection. And we changed them into Parse Object and Parse Collection. Now, the cool thing is that this works exactly the same way as the Backbone model. You can use the Backbone model if you want instead of a Parse Object, if you have just a transient thing like the game state. Or you can use this. It'll work just the same. The special thing is that when you save a Parse object, you don't have to figure out your own server configuration, point to your own database, et cetera. This will just automatically save it to your Parse database. And the collection works in a very similar way. You can fetch objects, set the query on it, and Parse will manage all the Backbone-y collection things. And there's more than just those two. We actually have a bunch of different classes in the Parse SDK. You can manage push notifications, users, of course, sign them up, log them in, manage the session. We have access control lists with those who saw David's talk are very familiar with now. We do queries, of course, so you can figure out exactly what data you want to get back, and a bunch more, of course. So let's try building something with Parse for this game. Let's do a simple high score to start. So how would we do this high score in the simplest way possible? Well, high score is really just a bunch of numbers, right? Attached to some user or some name at least. So a simple way, just client-side, I can just create a new Parse object of type high score. So I have a table, high score in my database. I set some value, which is the current score. And I set some player, which in this case I'm using the current user. And then I save it. And that's it. When I later want to show this, I'll have all this data here. We see the pointer to user, the score it got, and when it was created. Very simple. I want to get that data back for the, let's say, top 10 scores. I just do a query. Of course, I point to that high score table. I do descending order by value, limit to 10 to get the top 10, and I have my data back. And here I just use jQuery to add them to some list somewhere. And this would work just the same in iOS, Android, .NET, whatever platform you're using with Parse. This would be exactly the same thing. So the problem with this is that you can easily just open up the term or your inspector, write yourself parse.object.new, high score, set the value to 1 billion, say save, you're good to go. You've just hacked the high score. So the problem with high scores is that it's really completely impossible to actually secure that. Because the game is run locally and client-side, there's no way you can actually completely secure it. But you can do better than just this. So what can we do? We can use Cloud Code. So Cloud Code, for those who don't know, is basically a node-like environment that Parse runs and hosts, where you have access to the Parse JavaScript SDK, along with a bunch of other cool stuff. And you can write these functions that will be run on our servers. So it has a higher level of authentication. So what you can do instead, JavaScript in the cloud. What you can do instead is call some cloud function, in this case, submit score, and put the score in there. And then in my cloud function, I can do some checks. Let's say, it's literally impossible for you to get over 100 in my game. It'd be just ridiculous if you did. So I just say, OK, well, if it's higher than 100, reject it. Some simple validation. It'll make sure that at least there's no 10 billion number there. It'll be 100 at most. And then otherwise, you just create the same thing as before. It's a little bit of validation, nothing too fancy. So how can we improve this? Well, the big problem here is that somebody could still figure out, OK, well, I'm sending this request, And that's the exact number of my score. So I'm just going to try numbers until the one that works, which will be 100 or 99. And so instead, I can encrypt it in some way. Now, encrypting it is not true encryption because I'm not using some kind of private key. I'm just using some public thing they could find if they really look into my code. But again, it's better than nothing. Most people will see, oh, random string, I just won't bother. And then, of course, you'll have to decrypt it here, and then you can just reject the request if it's not good enough. But now you can do even better. You can do basically ping. So every time I actually score, I can send a request up. And I don't send the number, because it's always going to be the same number, let's say 1. And I send in what match. It matches 2. And so in my increment score, I'll say, OK, well, create a new kind of activity, let's say a score activity. I'll set the player in the match, and then just save that. Then later, I'll call submit score when I'm done my game. And I won't pass in any kind of number. I'll just say, OK, I'll query for all these activities and see how many I got. So I'll do a count query. And I'll just use that number as the score. So that at least kind of reduces the risk of somebody just putting in some random number there. They'll have to do some work. And if you want to go even beyond that, you can say, all right, well, what's the delay between each of my increment score calls? In my increment score function, I say, OK, well, when was the last one created? And was it 0.001 second ago? Then it's probably impossible. And this person is probably hacking me. Or was this called a year ago? Well, the session is probably done by then. So you can do these kind of heuristics to make it as secure as possible. At the end of the day, you're basically stuck doing as much work as you're willing to do to secure your high score. And the only way to truly have an unbreakable high score would be to run the entire game on the server. And that's what games like World of Warcraft or these other kind of online hosted games do. But in this case, if you do want to run your game client-side, you basically just have to go as far as you want. And there's kind of an endless possibilities of kind of these blocks and obstacles you can add. But if you go into basically any game in the App Store today, you're going to see some score at the top that's basically impossible to reach. But a great way to minimize that is just don't use a global high score. If you want to use kind of a Facebook kind of game, just do a high score with your friends. Say, this is what your friend group got to obtain. Or if you want to do a local thing, just say, OK, well, these people got that score around you. In a 20-mile radius, these are the highest scores. So you kind of reduce the possibility of saying, oh, OK, these are just arbitrary scores, and this is kind of boring. I can't really compete with this. So that's high scores. Probably the coolest feature that you can do with Cloud Code is asynchronous game matching. So if you look at a lot of games today, like Draw Something, Words with Friends, they all have this really cool new paradigm, which is I play my turn. I'm done playing. I say, OK, submit. And then my friend or some stranger somewhere gets a notification, and they can play their turn. And it works really well on mobile because I don't have time to just sit there and play a game for 20 hours. I just want to play every now and then on the bus or on the BART. And so for doing asynchronous game matching, it's a little bit tricky if you want to say, start me a game with a stranger. I don't have any friends playing this yet. Just start me a game. And it's a little tricky, and we'll see why. So if you want to do this, the first step is, OK, I need to find an available match somewhere. Hopefully somebody created a match at some point. I need to find an available one. Once I have one, I say, OK, well, I have to try and join it. I say try to join it because there's a big race condition here where multiple people can be trying to join the exact same match. And we'll see a bit more about that in a bit. Now, if I can't find one, of course, I can just go ahead and create a new game. And if I successfully join the game, I set myself as player number 2, and we're good to go. And if I fail to join it, then you can retry if you want. It's kind of simple to just create a new game in that case. So we'll go through this little flow diagram in code. So first, to find an available match. This is kind of a heuristic you kind of have to tweak a bit, but you basically want to find a way to get a somewhat arbitrary match so that not everyone always tries to grab the same one. But at the same time, you have to make sure that you're not starving any matches. So there's not one match in there that just never gets another player. So one cool way to do this is, OK, well, first I'm going to query the match table. Of course, I have to find just the ones that are waiting for a player, hopefully the ones that aren't created by me. And now I'll look for the oldest ones. So I'll say, OK, created at ascending, so in chronological order. And I'll just take the top 10 ones, so the oldest 10 ones. And that makes sure that even though there's 100 games waiting, I'm not going to have one guy just waiting there indefinitely. There's a problem with this that if I just pick a random of these 10 all the time, one of them could never get picked. It's very unlikely, especially if you have enough traffic. But if you're worried about that, you could just do kind of a weighted average and say, OK, well, the oldest gets a higher priority than the 10, but it's still somewhat random. And then you'll just look for all these matches. So when you have these, what do? Well, the first case is I didn't get anything back. In that case, I just create a new match and save it. There's probably some more setup you'd want to do there, but you get the gist. Now, if I do find one, what do? Well, I'll start by picking one of that array I just got of matches. And here I'm just saying, OK, well, pick a random number between 1 and 10 and return me that match. Now, I can't just set myself as player 2 and call it a day, because there could be 5 players right now that just all ended up picking this one match and all want to join it. So what you want to do is use a semaphore. So this will be just a number on that match that will be 1 if you have 1 spot available for a player. In our case, it's a 2-player game. The first player created it, so I can have 1 spot for another player. And I'll need to use an atomic operator. What that means is that I'm going to say increment or decrement, and that will do that operation atomically. So it'll increment it by 1, regardless of what the previous value was. So if you think about incrementing a number, what would you do? Well, you would get the current value. You would say that plus 1, and you would set that as the value. The problem is that if you and me both do that at the same time, we'll both just set that value to 2. If we both use increment, I'll set it to 2 if I'm first. You'll set it to 3. And then that incremented it properly. We didn't both just set it to 2. So the cool trick we can do here is say, OK, well, our match semaphore is supposed to be 1. So I'm going to decrement it, so increment by -1. And I'm going to see, OK, well, what is the value I get back? So I'll first increment it or decrement it by 1, save it. And in the return function, I'll say, OK, well, what did I get? Is the value 0? So if I decrement it by 1 and I get back 0, it means, great, I got the match. I got that semaphore. If I get back -1, it means somebody beat me to it. It means they decremented to 0, they got the 0 back, and I'm getting back -1. So I can say, OK, well, I failed. So in this case, if it's below 0, I'll just say, OK, I'll create a new match. And notice here I'm creating the match with a semaphore of 1. So I'm setting that value. And then, of course, if I do get that match, then I can just go ahead and set myself as player 2. And, of course, change the status to playing or do any kind of bookkeeping you need to do. And I save it. So with just this, it's actually fairly simple to create this flow of matching random players together. And it's completely thread safe. It's completely safe to have this scale to 1 million people. And this is actually a question we got a lot on our forums especially. Is it possible with Parse to do this kind of managing these race conditions? And that's where the atomic operations come in. And you can actually use this same principle for pretty much any of these circumstances. These atomic operations can help you basically solve all these race condition problems. So you can use Parse, do a really cool backend with cloud code, do all these cool gaming features. And then you can use Backbone.js on the front end, have all this really nice, well-organized and structured code, and of course use the Parse SDK in there somewhere. But there's not everybody that loves Backbone. We love it. We actually use it on our entire website. If you go and you inspect our page, you'll see Backbone there everywhere. But some people prefer things like Angular.js or Ember.js. And you're actually completely free to use that along with Parse. We don't dictate Backbone in any way. Our framework includes a lot of the Backbone parts because we are built on top. But it'll work perfectly fine with any of these other frameworks. And you can just say, parse.object.new and save it. If you do use Backbone, you get the niceties of these events already being triggered for you. But you can easily wrap that and make it work with any of the other frameworks. And so now the game I just showed, the NEO game, is completely open source. For those that are curious, that's actually really cool how it works. There's no JavaScript for any of these animations. It's purely CSS3. And it's actually really nifty how it all works. And of course, all the view management is all done in Backbone, as well as the model. And so you can check it out on GitHub. It's open source on the Parse platform account /NEOC. And we have a landing page on our website you can check out, but there's really not much there. And yeah, that's really it. I want to let you guys answer any questions you may have.
You guys just recently announced the whole thing with the integration with Unity. How much does Backbone work with that, and a lot of the integration that you guys got done?
Yeah, so basically all I talked about for like high scores and asynchronous game matching, that's just cloud code. And our cloud code environment runs our JavaScript SDK. So you're free to use that as much as you want, and that will work exactly the same way. The Unity SDK is actually built with C#. So Unity uses C# as its main language, and it's kind of a completely different paradigm for programming games. So if you wanted to build a Unity game, you could definitely just like figure out how Unity works, build a cool game with that, and use cloud code on the back to power these things like the high score and the game matching.
So what sort of tools do you use when you're debugging your Backbone code?
Personally, I use Vim and Sublime Text to code kind of interchangeably, and really just the Chrome debugger. It works pretty well, and it's much better than it was 5 years ago when you didn't really have the nifty stuff you have now, like the network inspector and all. It's really great. Mm-hmm.
Apart from the incrementing and decrementing thing to figure out who got there first in your race condition, like I'm thinking how I'm going to make a shopping bag for this shopping website I'm making. Are there any other methods you'd recommend for that? Because it just seems like it wouldn't always work.
Well, so what would be the race condition for your shopping bag?
Just that maybe someone would buy something that was out of stock, that kind of thing.
I see. Well, actually, that'd be like the perfect use case. You have a number you're trying to decrement. I mean, it's not like the greatest kind of like metaphor for all cases, especially when you're like not dealing with a number. But in general, you can pretty much solve any race condition problem with just any kind of atomic operator like this. You might have to do some kind of like acrobatics to say, this number really presents this. But in general, it'll just work.
So you haven't had any cases where the person's decremented it and then they get the value again, and then their server is just slower than the other person's or something. They're running some slower hardware or something, and they didn't really win the race condition or something, like.
No, so because that's all server side, right? So like you'll say increment, and I'll say increment, and then you have the parse servers, and we'll do the correct thing and return you 0 or -1 or -2 or whatever it may be. And regardless of the speed of your hardware, like unless you crash, and that 0, if you got the game, you just like never end up getting matched, then that kind of be a problem. But I would assume that's a bug on in your own app rather than Parse. So.
Cool. Thanks.
So using your current metaphor, how would you, for example, the case of somebody could drop out of the game and drop back in if you're constantly decrementing?
So you can like quit the game. I mean, I think most apps, if you quit the game, it just kills the game. Right. So you would want you can quit the game and then rejoin.
Yeah, you
somebody else would fill the spot.
You could just drop off. Someone else can. Fill the spot.
Yeah, I mean, when you drop the game, just flip the status back to waiting, increment the semaphore back to 1. I think that would just work.
What's a good example for a Backbone come Parse app? Is it the any yoke?
Yeah, so if you want like a coding example, that one is pretty thorough and pretty like good Backbone practices. I mean, in general, Backbone is used a lot for more of like business line apps, so like to-do lists. I think Hulu uses it. A bunch of some fairly big name companies use it, and it doesn't have to be a single page app. You can just use it page per page, and it's really great for just saying this kind of view here has all my videos, and this view here has this list of videos, and helps you organize that code to not have them all talking to each other.
Okay. We use AngularJS a lot, so I'm just trying to see if you have an example that talks to Parse, from an AngularJS client.
Yeah, so we don't have like any gripe against Angular, Ember, any of these other guys. And we've actually been looking into either creating an SDK maybe that works a little bit better with those, or at least having examples of how you can properly use both and little wrappers or something. But that's probably a bit further down the line. But if you have any particular questions about some issue you run into, we'd love to hear about it, and we'll try to work through it with you.
Cool.
Any other questions? Don't be shy. All right, cool. Well, thank you very much, guys.